Okay, hopefully you got sound. Hopefully you got sound on FB. Okay, that's the biggest issue with this online teaching because there's no immediate feedback. Okay, there's no immediate feedback, so you do not know whether uh, the lecture is going on live or not on FB. Okay, so right now 8:29, 1 more minute to go. We already got 27 out of you all. There's supposed to be 29, so I'm still short by 2. Okay, 8:30. I need to switch off the attendance screen. So whoever that's late, we will check on your attendance later on. Okay, Ayu just masuk. Okay, Ayu, welcome.
Okay, Prof. Tak dapat nak masuk tadi.
Okay,
QR code.
alright. Okay, so kena screen kecil sikit baru boleh nampak. Alright, so I'm going to minimize the screen. Okay, basically I'm having a 4-screen setup here. So the 4-screen setup allows me to see everything. Okay, everything is being switched through OBS Studio and also on using my Atem Mini. So I'll be switching from my camera and my OBS Studio. Okay, so on my switcher, I'll be switching from my PC. So this is my PC. Okay, then this one is my camera. I'm sorry about the title there. Sorry, what we call OSD, online screen display. I'm not using my GoPro. Why I'm not using my GoPro? GoPro got delay. GoPro got delay. So right now I'm using my SJ cam. Turn out the model that I bought, the SJ cam does not allow for me to switch off the OSD, the online screen display. That's why it's so cheap, 140 ringgit only. The GoPro cost me 900 bucks, but I got delay. Alright, so the camera that is being used to show you all to me, to show me to you all, is another one camera, Insta360. So I got 3 action camera here. I got GoPro, I got SJ Cam, I got the Insta360. Alright, so that's my setup. So as you can see, I got 2 computers. One computer for streaming and one computer uh, for teaching you all. Okay, so the streaming computer is also being connected to Microsoft Teams at the same time. Okay, so that's the explanation. All right. So some other problems on for those on FB. If the whole thing becomes too heavy for the OBS Studio, suddenly the OBS Studio may disconnect, and when it disconnect, we will have problem of no feed to the online one. So whenever that thing happens, means there'll be a short delay on for those on FB, but not for those here who are on Microsoft Teams. The Microsoft Teams will go on as usual. Okay. So now I've started recording the lectures uh, on on okay. Okay, there's a problem here. I'm start I'm starting to record the lecture on Microsoft Teams. The one on Facebook is also being recorded. All right. Okay. So next thing for me to do is to make sure that on Teams I'm spotlighted. So I'm selecting Spotlight Me. Okay. So I'm supposed to be spotlighted. You're supposed to see the bigger picture of me inside Microsoft Teams. So hopefully you'll be able to see all the slides. Okay. So let's start with the lecture proper. Okay. Yeah, so I'm now going to jump to the screen. Okay. Okay, that's a slight problem. I need to have both the FB and uh, the lecture to be displayed. Okay, so I'm going to push the Facebook page to the other screen. Okay, why? Otherwise, I will not know if the line is disconnected or what. Okay, that's one. So the other thing is I'm going to shift the OBS Studio back to my main screen. Okay, so I'll be jumping from screen to screen. Why do I have to see the OBS Studio? Because that one will show whether I'm covering the text or not. I think there's a slight problem here. This one is where the green screen cut off. So you can see this is a green screen. So when the green screen cut off, there is some area that is not properly covered. Nothing much I can do about that. Okay. So whenever you have a problem of seeing the text, uh, whenever you have a problem, just shout out and I will share the screen directly. Okay. Then it should be clearer to you all. Okay. So whenever you have a problem to see the slide, you can see whenever you have a problem with the slide, just tell me and I will adjust it accordingly. Okay, I'm not sure why suddenly my screen keeps shutting down. Okay, alright, so let's start with the lecture proper. Okay, as usual for the lecture, everything is on drtamil.me. Okay, as stated on the scrolling text, I have a blog. The blog is drtamil.me. Okay, you just go to drtamil.me, click on FK6193. Click on FK6193. Okay, you can see here the list of topics. So for today, we're covering the general linear model, repeated measures. Okay, so I keep hearing this sound, tinning, tinning. I'm not sure it's coming from where. Teams good. Okay, never mind. Okay. Uh, oh, Sumi asking, exam SPSS macam mana? Exam SPSS for you all is in as scheduled, which is in on the 15th of January. Hopefully by then, you all can come back already. Hopefully by then, you all can come back. If you all cannot come back, then we will adjust. But as usual, we already stated before for the exam SPSS, the sample questions are already at openlearning.com, so you can just go and try it out. Alright, so that was a question from Sumi. I hope that's clear. Okay, so Atika message me. Atika terkeluar kot. So let's look at Atika. Okay, je. Ya. Aku tengok lagi ada input I. Ada input tak ada. Okay, so very sorry about that. Atika message me, but I cannot see her message. Let's see whether I can see it somewhere else. Okay, I got my iPad here.
Saya dah masuk, doktor.
Dah masuk ah? Okay, sorry. Okay. Okay, sorry. I punya handphone tak ada kat sini. That's why uh, the alert came out, but I don't have the handphone. All right. So there's a story about exam and message from Atika. Okay. So let's start with the lecture proper. Okay. So what are we covering today? We are covering GLM repeated measures. Okay. So basically all the lectures covered in the second half of the semester is designed to help you all to do multivariate analysis for your project. So for your project, if your outcome is dichotomous, you have logistic regression. If the outcome from your research project is continuous, you have multiple linear regression. If the outcome of your project is pre and post, so you have an intervention, so you have a pre and post, and then you will have to do general linear model repeated measures. Okay. As for survival analysis, if you're doing time to event, that's survival analysis. If you're doing uh, multivariate for time to event, then you have the Cox regression. If you're trying to control for confounders, you have the mental Hansel test. So all these topics are designed to provide a solution for your needs for the research project. Okay? Okay, just give me 2 minutes. I just get my phone up. All right. Finally, I got my phone. Very sorry about that. Okay. Right. Okay. So the message was from Atika. Okay. So okay, let's go to all these things. Okay, as stated just now, this all these thing we are teaching you is so that you can do what you need to do for the research project. Okay, so why is the GLM repeated measures something that I don't want to cover earlier? Because it is something very difficult to understand. And in fact, before this, we did not know about the GLM repeated measures. We only discovered about this quite recently. I went to Bangi to study about statistics and they exposed me to GLM repeated measures. And that's when I realized that a lot of my analysis that I did before could have been done better by using GLM repeated measures. Uh, so to as like what one of your friends stated, it is very hard to learn without a teacher. It is very hard to learn about a teacher. So from the uh, Singapore Journal of Medicine, Singapore Medical Journal (SMJ). Okay, so all these materials are available from my blog. Okay, you just go to my blog. On the search button, type the word basic, press enter. So you can see on the list of search, basic statistics for doctors. Okay, so you have the basic statistics for doctors. Somehow it's not coming out. I thought the word basic kan. Sometimes it works, sometimes it does not work. Okay, it's not coming out. So my apologies. Okay, so I do not know why it is not coming out. Okay, yes, silakan. When you're trying to show off something, you're not a problem. So click on references. Under for references, we have the basic statistic for doctors. You click on basic statistic for doctors. There's a password. The password is YH Chan. YH Chan. Okay, click enter. Then you can see all the articles available there. Okay, so in fact, this list of articles is compulsory reading for those who's taking FK6163. For those who are taking FK6163 basic statistic, you have to read from 101 until 301. Okay, until 301. How about the rest? The rest we already covered also. We already covered principal component analysis. Okay, the rest we are going to cover during the advanced step. Okay, so based on Waishan, you can see here, it was published in August 2004. Okay, so the nice thing about Waishan, he covered everything. He covered everything. Okay, so you can just refer to his set of notes to learn about repeated measurement analysis. So today, for today's lecture, I am going to cover this article 301. Okay, there's two set of notes. There's 301 and there's 301A. So I'm just going to cover 301. Okay, so let's look at the 301. Okay, so everything has been arranged nicely as under the FK6193. You click on GLM repeated measures. Okay, the top one is the article that I showed you just now. To make life easy, I have the PowerPoint already prepared. Okay, so you can just download it and play it back. All right, so let's start the lecture proper. Yeah, I'm going to download this. Why download? Usually when you download, they will trigger the Acrobat Reader to play it back. But I think might not on my own notebook. Okay, so I hope you can see this clearly. All right, so let's make this thing bigger. Full screen. Okay, I'm going to make it bigger. Bigger, bigger, bigger. All right. Okay, so we are going to cover this topic. Okay, some slight problem here. I'm getting a feedback. A feedback happens when you are using a speaker, and when you are using a speaker, whatever I say is repeated back. All right. So, okay, thank you. Okay, so this is GLM repeated measures. Okay, so let's start with the lecture proper. Okay. Okay. Why do we need GLM repeated measures? If we are doing a pre and post, if you're doing a pre and post, for example, you are doing a study on bariatric surgery. So you have a study on bariatric surgery, so you have a group of medical students, you have a group of patients who underwent bariatric surgery. So you measure the weight before, you measure the weight after. So the interest here is there an effect over Is there any effect on the outcome based on the intervention, which is bariatric surgery? So there's a problem here. Okay, if you have only 2 time points and you have only one group, okay, no problem. You don't have control, you have just pre and post, only one group. That one you can do a PET test. Okay, that one you can do a PET test, no problem. Okay, if the outcome is categorical, you can do, if the outcome is categorical, you can do Magnema test. But life is not that easy. Life is not that easy. Okay, Atika asked, this one masuk exam? Nope. Anything after the second sem tak masuk exam. Anything after the mid-sem break tak masuk exam. It is only for your project. Which project? The one that you're doing in second semester. Okay. So you have a pre and post. Senang buat PET test. But the problem arises when it is not just pre and post. Doctor, we take the results over many times. We take the result baseline, 1 week after, 4 weeks after, 6 weeks after, 8 weeks after. So if you're taking the results over many point in time, you cannot do a PET test because PET test can only do at 2 points in time, at the start and at the beginning. All those measurements in between cannot be taken into account. So that is a problem with the PET test. So for that we need to find another statistical test that can do all the analysis for all the time points. For that we have GLM repeated measures. Okay. Okay. Doctor, we can do other things. Yeah, can. Okay. If you are interested in the overall treatment effect, okay, for example, you're checking the BP after treatment with bisoprolol. Okay. So then you take the BP as a start. You take the BP after 1 month, 2 months, 3 months, 4 months, 5 months. You can take the average of the blood pressure for each month. Okay. But that will only give you the overall picture. It does not give the changes over time. If you do 1 month versus 0 month, 2 months versus 0 month, 3 months versus 0 months, 4 months versus 0 months, 5 months versus 0 months. When you do this many times, you end up with what they call inflated type 1 error. Yeah, inflated type 1 error. So treatment standard errors are less accurate since only the observations at each time point is used. So this must be discouraged. So, or you can use other methods. Okay, you can use area under the curve. You can look at the minimum and maximum values, and or how much time before you can get the maximum effect of the drugs. Okay, so those are some of the other methods that you can use to come up with the answer for this kind of analysis. But today I'm going to show you how you can analyze everything at one go. Okay, so here is the data set as given by Waishan. Okay, as you can see, the data set is not that much. There's only 12 data set. Okay, so what is this data set about? Data set is about level of anxiety. So you have two groups of people. One is I'm reading some of the comments dengan dekat Facebook, saying that it's related to your study. Yes. Okay, so you have two groups of people. One is of high anxiety level, the other one is of low anxiety level. Okay, so you have two groups of people, high anxiety, low anxiety. How you all apa? High anxiety, low anxiety? Right now I know SSKM dengan SKM, JKM tengah high anxiety level. Why? Proposal tak siap lagi. Deadline 2 bulan oi. Deadline submit proposal 2 bulan kan?
19 Prof.
Okay, but then must be the executive group lah. So executive group have to submit the turn in their thesis on the 2nd of January. 3 days from now. Oh, 2 days from now. Today 31st. Okay. So right now, okay, I just check, try to see what is causing this thing to be keep disconnecting. Whatever I can shut down, we shut down. Nothing. I cannot shut down anything else. I got only 4 screens up. I got only 4 windows up on my PC, and the rest have all been shut down. Okay, so this is data set. High anxiety, you make more mistakes. Low anxiety, you make less mistakes. So we are trying to prove that in terms of number of mistakes, the high anxiety makes more mistakes compared to the low anxiety group. So for this group, okay, for this group, we have the data set. Okay, I'm going to make this small, if it is possible. F11. Oh, okay, boleh. Alright. Okay. I think you can guess already. The data has already been entered. It is inside here in SPSS. Inside SPSS. The data SPSS is inside my block. You click on the data SPSS. You can open it up. It will come out in SPSS. Okay. Nice thing about doing it like this, because I got 2 separate computers, everything will be changing on my other computers. There is no need for me to adjust the OBS Studio here to capture the correct screen. So I don't have to worry. Just wait for the other screen to come out. I'll be okay. Okay, so now I got my special screen up already. Okay. Sorry about that. The shadow is getting worse. So I had to bring down the curtain. So right now you're seeing me, the color pink is not because I'm pink in color, but because the screen is pink in color. So I'm getting all pink color coming on my face. But at least my green screen now is not working again. So you can see here, this is the same data set like inside the Waishan. Okay. So we're going to run the analysis based on this. Okay. So using GLM repeated measures, okay, you can answer the following question. Okay, number 1. Is there a difference in number of errors made by the high anxiety group? Okay, is there a difference in number of errors made by the high and the low anxiety group over time? Is there a reduction in numbers of errors made by the trials? Okay, is there a time trend? Okay, sorry. Uh, and if you have two groups, is there a group time interaction? So, for example, you got a treatment group, you got a control group. Is there a difference between the treatment and the control group? This is my right side. This is my left side. Okay, correct. Okay, So in this case, we don't have that same problem. Why we don't have that problem? We have only one group. So let's say we have only two groups. Okay. We have two groups. And the two groups are high anxiety and low anxiety group. So right now we're going to see whether there's a difference in terms of analysis. So I'm going to show you how the analysis is done in general linear model repeated measures. So I'm going back SPSS. So you're supposed to see the SPSS right now. So when I click SPSS, I click analyze. Analyze. Okay. There's general linear model, repeated measures. Okay. So they ask you to put in the factor name. Okay. Here you have trial 1, trial 2, trial 3, trial 4. But we are not really interested in the trial. We are doing a study on errors. So my suggestion, when you do the analysis, then you're supposed to give a name for that analysis. You choose the name of the thing that you're studying. Here, I'm studying the number of errors for the different tiles. So I'm going to put the name error. Okay. How many levels? If you look here, you got 1, 2, 3, 4. 4 level. So you put in 4. Okay. You click add. After you click add, you highlight that add. Then you define. Okay. So when you define, you have the 4 trials. Trial 1, trial 2, trial 3, trial 4. Transfer it to the right. You can see 1, 2, 3, 4. So when you're giving labels to your variable name, make sure that so that you can arrange them accordingly. So they become like this, arranged nicely, 1, 2, 3, 4. You got two groups of people. One group of people is high anxiety. Another group of people is the low anxiety group. So how are we dividing these two groups? We are using the group variable anxiety. So click anxiety. Okay. So now we got everything prepared. 1, 2, 3, 4. We got anxiety. Okay. Next, we have to decide on the analysis. Okay. So first we decide on the grouping. Okay. Change. This one I know they put trial, but I don't like trial. Because to me, what we're studying is errors. So I put errors. Okay. So we bring everything there. Then you click OK. Then we click OK. Kalau based on this one, this is the basic one. Okay, the basic one. We are going to do this again and again, many times. Okay. So I'm just going to proceed with the analysis, but just so that we get a picture, I'm going to click on plot. So what is the plot? What is the horizontal axis? Horizontal axis, flat line. Vertical, tegak. So horizontal axis is the x-axis. So for the x-axis, I'm going to put error. For the separate lines, we got two lines, high anxiety, low anxiety. So we're going to put the anxiety group into separate lines. Okay. Then we click on add. Okay. So you can see there, they're going to plot error by anxiety group. Continue. Okay. There are other options. Okay. We have the model. Okay. In this case, when we cover next semester, I'm going to cover more in detail what's the difference between full factorial and the custom one. Okay. Under the sum of squares, we got many types. Type 1, type 2, type 3, type 4. That one we are going to cover next semester. This semester, just enough to teach you all for your project. Click continue. Okay. Contrast, I'm not going to do contrast here. I'm not going to do contrast. Okay. So let's not worry about that. Okay, plots we already covered. Post-hoc, okay, if you have more than 2 groups, then you have to do a post-hoc test. But since we got only 2, there is no need to do a post-hoc test. Okay, for options, okay, you can do analysis by the time. You can do analysis by the group and so forth. So this is you want to see the mean by each time difference. You want to see the mean for anxiety. You want to see mean for number of errors. You can click here to select that. Okay, so our interest is in trying to see whether the high anxiety group and low anxiety group got different or not. I'm going to display the means for anxiety. Okay, so I'm just going to set this for bone colony. So you can set everything there. If you do not know what to click, just click everything. If you do not know what to click, just click on everything. Okay. I think that's enough. So we should take effect size. I'm not really interested in effect size. Okay. Once done, you click on OK. And you get lots and lots of tables for your answers. Okay. The lousy part about the GLM, repeated measures, the results is not arranged in any particular order. The result is not arranged in any particular order. Okay. So you have to scroll up and down accordingly. So you can see here, we have 4 different time point. Time 1, time 2, time 3, time 4. You have 2 groups, low anxiety group and the high anxiety group. Okay. Since I already asked for the descriptive statistic, they give me the mean for each group at different point in time. Okay. But looking at this green line. Okay. Okay. So now I'm reconnected back on FB. Okay. So you can see that in fact there is not much difference. You can see that there is not much difference. This is trial 1, trial 2, trial 3, trial 4. These are the number of errors made. Okay, eyeball analysis. Make sure your eyeball is connected to your brain. As the time increases, as the number of trials increases, the number of errors drop down. Like we say in Malay, alah bisa, tegal biasa. The more you do it, the more you are used to it, the less mistakes that you make. Okay. I really look pink in color. I should change the curtain. Okay. So you can see here, the number of errors drop as we increase the number of trials. So why? They make less mistake because they are more used to it. Surprisingly, these 2 lines meet after the 3rd trial. Okay, but then they diverge again. Okay, so that is how we look at it. Okay, let's look back at slides. Okay, there are 3 questions that you wanted to answer. Is there a difference in the number of errors made between the low and high anxiety group? Is there a difference in the number of errors made between the low and high anxiety group? Okay. For that, we do the between subject factor. Between subject factor is similar like you're doing Anova. It is similar like you're doing Anova. So for that, we look for the between subject factor. Okay. So you look at the results inside SPSS. You look on the left side. Test of between subject effects. So the test of between subject effect, this one is Anova. This one is Anova. So you can see here, for the test of between subject effect, it is not significant. Yeah, sorry. So you can see here, intercept is significant, but between the two anxiety group is not significant. The value is 0.460. Okay. I know you don't believe me when I say this is same like doing ANOVA. Okay. So I will show you by doing ANOVA. Okay. So I'm going to show you what happens for ANOVA. Okay. For ANOVA, we cannot have more than one group. Okay. Sorry, we have two groups, but we cannot have more than one results to be analyzed. So we have four results here. 1, 2, 3, 4. So what we do, we get the average. We get the average of 1, 2, 3, and 4. So this one is in fact the average of 1, 2, 3, and 4. So this is the average errors made by all the individuals. So now I will do ANOVA. So click Analyze, one-way ANOVA. So the dependent list is the number of errors. The factor is the anxiety group. Okay. So here you have post-hoc, you have options. Okay. You can set the usual thing. Okay. Does not matter because the only thing we want here is the table. So you can see here the F is 0.590. The p-value is 0.460 between groups. Between groups. So if you compare with what you do earlier, remember it is 0.460. 0.460. Okay, the F is 0.590. Same like this one. The F is 0.590. The p-value is 0.460. So what I'm telling you now, between subject effect, inside the general linear model repeated measures, is same like doing ANOVA. Is same like doing ANOVA. I know it is not stated inside the White-Shan notes, okay, but I'm telling you, between subject effects is same like ANOVA. Okay. Okay, next question. Okay, so overall, no difference. Overall, no difference. P-value 0.460, so it is not less than 0.05. So there is no significant difference of errors between the high and low anxiety group when you take the average. For number two, is there a reduction in the number of errors made over the trials? Is there a time trend? Is there a time trend? Okay. If you look in the SPSS, you can clearly see that there's a time trend. you can clearly see that there is a time trend. Why? As the time goes by, it is reduced. If there is no time trend, it is a straight line. Okay, but here instead of being a straight line, it is reduced over time. So over time, okay, over time, the number of errors is reduced. Okay, you can see clearly there's time trend. Problem is, how do we prove that it is significant? Okay, okay, let's look at the notes first, then we explain again. Okay, as you can see here, this is what we do. We compare the mean effects between the high anxiety group and the low anxiety group. Then we get the results, and the result is this one. This is the descriptive statistic by anxiety. So we can look at the mean of anxiety. You can see this one is 9.542. This one is 10.4. So the level of number of errors between the high anxiety and low anxiety is not much difference. Okay, the level of anxiety between the level of the number of errors between high anxiety and low anxiety is not much different. Okay, so for that you can see that the p-value, it is not significant. Okay, so I'm not going to worry about that one. Okay, this is the plot. Okay, you already saw the plot. Okay, what we are interested in is in the statistic. Okay, so what is the statistic that we're interested in? We want to know the time trend, the number of errors over time reducing, is it significant or not? So you can see here, you look at data, yes, it's dropping. 16, dropping to 11, dropping to 7, dropping to 3. So clearly there is a time trend. As the as the number of trials increases, the number of errors reduce. Okay. Unfortunately, they are not giving you only one choice of answers. You have two choice of answers. One is univariate, the other is multivariate. Please take note, this is univariate within GLM repeated measures. Multivariate within GLM repeated measures. Okay. Okay. Let's look at the univariate. Okay. This is univariate under GLM repeated measures. So this is univariate approach and multivariate approach. So what is the logic behind univariate approach? Okay, it must fulfill certain criteria. One of the criteria, it must have a type A structure or circular in form. Okay, what does it mean? If there is any correlation between any of the two levels of within subject factor, it is of constant value. Okay, so you have a correlation. Okay, at any of the two levels, it should have the constant value. So how do we check it? You check it by using the Mockley Sphericity test. So the Mockley Sphericity test is like this. Okay. Problem in the SPSS, kena cari. You have to look for it. Okay. The Mockley Sphericity test, you have to look for it. See this one? Mockley's test of sphericity. So you have to look for it. Okay. What is the requirement? The requirement is the p-value for the Mockridge Sphericity test should be larger than 0.05. If it is larger than 0.05, then you can assume that sphericity is assumed, and you can take the results from the sphericity assumed. So right now here, you can see that the p-value is larger than 0.05. Therefore, is there a change over time for errors? You take the first line. Why first line? Sphericity assumed. Okay. So based on sphericity assumed, it is the p-value is significant. Yes, there is change over time. There is change over time, and it is significant. Based on what we look at the graph, as the time increases, the number of errors decreases. And the number of errors decreasing is of significant value. Why? You can see here p-value is less than 0.05. Okay. Doctor, when we use the other thing, greenhouse gaseous, Unfeld, lower bound, I will show it to you later at the end of the example by Waishan. Okay. Next question. Okay. So this one already clear. P-value for Mockridge Sphericity test, the p-value is larger 0.05. So we can use the first line. So the first line shows that there is a reduction of errors committed over trials. Okay, p-value is less than 0.001. Okay, 0.0. Okay, doctor, the p-value is 0. There's no such thing as p-value is 0. Okay, so what you do, p-value is less than 0.001. Change the last value to become 1. Since you put less than, then you're still correct. If this one is larger than 1, then when you round it up, it won't become 0. Okay. Okay, next. Okay. So that is the univariate approach. Univariate approach is only valid if sphericity assumed is larger than 0.05. Then you can take the first line, which is sphericity assumed, and you get the p-value is significant. Yes, there's a change over time. There's a change over time. The other approach is applied if the sphericity assumed concept is not valid. You get a p-value less than 0.05, or there is no p-value, or there is no p-value. So for that, we will use the multivariate approach. So how do we check for multivariate approach? We check for the box test. Remember just now what we did? We click on the homogeneity test. So when we click on the homogeneity test, we are checking for the between subjects variance covariance. Okay, the homogeneity of the between subjects variance covariance is checked when you click on the homogeneity test. Okay, so multivariate approach assumes that the correlation for each level of the within subject factor is different, and the vector of the dependent variables follows a multivariate normal distribution with the variance covariance matrices between being equal across the cells formed by the between subject effects. Yeah, I know it's very hard to imagine that, but try to imagine the line. As the line coming down, are the lines having a constant correlation, or are the correlation changing at every different point of level? So that's make a difference whether you use univariate or you use multivariate. Okay, so let's go to the next part. So we look at the homogeneity test. Okay, again for the homogeneity test, for the box test, you want it to be larger than 0.05, which will show that it is homogeneous. That will show that it is homogeneous. The homogeneity assumption is holes. Okay, again, inside SPSS, it is located not in a coherent manner. So you have to look on the left side. Just now we said we look at the univariate first, but in fact we get the box test earlier than that. Then we get the multivariate, then we get the sphericity test. So you can see here, this is the box test. So the box test, the p-value is 0.315, so it is larger than 0.05. Therefore, the multivariate results is also valid. So you can take the multivariate result. So you can see here, the problem now for the multivariate results, they are not giving you only one. They're giving you 4. Yang mana satu pilihan kalbu? Nombor 1, nombor 2, nombor 3, nombor 4. Okay. So, trying to decide which one to choose is difficult. Okay. So here, we said we can see that the multivariate is valid. So we can run the analysis. Okay, we can use the analysis. But again, as I started earlier just now, you're not limited to one result. You have 4 results. You have Pillai stress, you have Weeks lambda, you have Hotelling stress, you have Roy's largest root. Some book put Roy's greatest root, but it means the same thing. So I myself don't understand why they choose the word largest or greatest. Okay. Again, the answer is significant. P-value is significant here. You can see that. So it just show that yes, there's a time trend. There's a time trend. As the time increases, the number of mistakes is less. As the number of trials increases, the number of mistakes made is less, and it is significant. P-value equals to 0. So argument now, how to explain? Okay, explain to who? It could be your supervisor, it could be your examiner. Which one to choose? Is it the first one, P like trace? Is it the second one, Weeks lambda? Is it the third one, Hotelling trace? Or is it the last one, which is Roy's largest root? Why SPSS can't show just only one? Why they have to give 4? Okay? Okay. In our case, result is the same. The 1, 2, 3, and 4 is the same. Okay? 1, 2, 3, and 4 is the same. If they are all the same, you take Pillai stress. You take Pillai stress. In the event if the result is different, you take Weeks lambda. Okay. This one is not available inside Waishan. This one is based on looking up the materials. Okay. So these are 4 different tests. And each one of these tests is somebody's paper, somebody's thesis, somebody's PhD. Okay. So the multivariate test table displays 4 tests of significance for each model effect. In analogy to the univariate test, the ratio of the hypothesis SSCP matrix to the error matrix is used to evaluate the effect of interest. More specifically, they are looking at the eigenvalues of the test matrix defined by the matrix product of the appropriate hypothesis SSCP matrix, and the inverse error of the SSCP matrix are used to compute the statistics in the multivariate test table. Wah, berasap. Okay. So there are the numbers were generated from some values. Okay. So how were they derived? Okay. So Pillai trace is a trace positive. Sorry. Pillai trace is a positive value statistic. Increasing values of the statistics indicate effects that contribute more to the model. So the larger the Pillai trace, the more is the effect to the model. Which lambda is the same thing. It's a positive valued statistic that ranges from 0 to 1. Okay. This indicate effects that contribute more to the model. So this one same like Pillai trace. Lagi besar, lagi bagus. Okay. But hoteling trace is always larger than Pillai trace. Okay. Hoteling saja is always larger than Pillai trace. But if the eigenvalues of the test matrix are small, they are about the same. So hoteling and Pillai trace is about the same. Okay. Okay. Royal largest root is the largest eigenvalue of a test matrix. Thus, this is a positive value statistic for which the increasing values indicate the effects that contribute more to the model. Royal largest root is always less or equal to the hoteling trace. When these two statistics are equal, the effect is predominantly associated with just one of the dependent variables. There is a strong correlation between the dependent variables, or the effect does not contribute much to the model. So that's the sum of the explanation about the 4 different tests. So we got Pillai trace, we got Lewis lambda, we got Hotter's trace, and we got Roy's largest root. Nice, but for us, we are just interested which one to use. Okay, again, based on my reading, Pillai trace is more robust in the other statistics to violations of model assumption, so we tend to follow Pillai trace. Okay. Each multivariate statistic is transformed into a test statistic with approximate or exact F distribution. So although they have all different statistics, everything is converted to become F value. So the F value is converted to become the P value. But you can see that the degree of freedoms are different for each type of test. You can see that inside the results. Okay, so let's look at the results. So you can see here, okay, this degree of freedom is the same, they are all 8. Hypothesis degree of freedom is 3. Why 3? You've got 4 levels, 4 minus 1, so it becomes 3. So hypothesis degree of freedom, we got 3. Error degree of freedom, we got 8. Because you have to remember, you have to do comparison between all the groups. Okay, so you got 4 groups. Okay, for the first observation, you have 3 comparison, 2 to 1, 3 to 1, 4 to 1, so 3 comparison. Then for the number 2, you have 2 comparison, 4 to 3, sorry, 3 to 2, 4 to 2, so 2 comparison. Okay, so tadi 3, 2, then we have 1, which is only between 4 and 3. So, how to calculate degree of freedom for the error? So, 4 plus, sorry, 3 plus 2 plus 1. So, you got 6. Okay. Okay. So, now I forgot which, apa lagi yang kita campur. Okay. Once I remember, I'll check it out. Okay. So the error degree of freedom is sort of same like the formula, 2 by the power of 3. So 2 by the power of 3, we end up with 8. Okay, we will see that later. We go through about that later. So don't worry. This is generated by the results. Okay. So we have all these analysis. We have all these results. But the one that we look is just p-value, and the p-value are all the same. Okay. Okay, let's look at the notes again. Oh, I keep looking at the wrong place. Okay. So we already stated P trace. If it is different, then you use with Samda. But there are some authors that like this one is by David Carson. David Carson says uh, if the box M test is significant, you use P trace. Okay, the larger the P trace, the more even effect contributes to the model, and P trace is always smaller than Homogeneity. So this one, if you're looking for the book by David Carson. David Carson say don't use P trace, always use with lambda. You only use P trace if the homogeneity test is significant. So it's very confusing. It's very confusing. So it's very hard to decide on all these factors. So on my part, I just follow Wai Chan. Wai Chan say always use P trace unless they are all totally different. If they are all totally different, then I will use with lambda. Okay. So we got two set of results, and both set of results are valid. Both the univariate and the multivariate were valid. So which one should you use? Okay. So what is said inside what is Chan? We use the sphericity assumption first. If satisfied, use the result from the univariate procedure. Otherwise, proceed with the multivariate one. Multivariate not valid, then you go back to the adjusted univariate. Okay. So this is table given by Wai Chan. Okay. You got two choice. One is you take the average, then you do the test between subject. Or, but take note, you just do this one. You just take the average value of all the results. This one, okay, you're looking at the real values as they are measured at different points in time. So, trying to decide which one to use, okay. You look at the sphericity. So, sphericity is, yes, you take the univariate test for within the subject. So, you take sphericity assume for the univariate. If sphericity is not assumed, you go to the multivariate. If multivariate not valid, then you go to adjusted univariate. Okay. So you go to the adjusted univariate. So in short, if the Mockley sphericity test is less than 0.05, you proceed to multivariate. Select the appropriate test values at the check box test. After checking the box test, select the appropriate test values after checking the box test. So you look at the multivariate. Multivariate is the checkbox. The checkbox test indicate that it is valid. Then you can either select Pile or you can select the Wicks lambda. If the box test is less than 0.05, Then the multivariate homogeneity assumption is breached. You proceed to adjusted univariate. So adjusted univariate, you got three. We have greenhouse geyser, you have Hunefeld, and you have the lower bound. So which one to use? Okay, this one is not inside the White Shan. This one is not inside the White Shan. It is based on extra reading. Okay, this example is given when the Mockley test of sphericity is not given. Mockley test of sphericity is not given. So it is not given larger or smaller. They do not give at all. Okay. So what is the problem here? The Mockley test does not provide any results if the sample size is less than the repeated measurement count. If the sample size is less than the repeated measurement count. In this example, this is a study on effect of drugs over 5 different points in time. And the sample, there's only 33. So not surprisingly, they have a problem. There's not enough to generate the necessary results. So they will leave the p-value for the Mockley test of sphericity as blank. So when you have this kind of situation, you look at the multivariate. So you can see here, for the multivariate, also not valid, because there are fewer than 2 non-singular cell covariances matrix. Okay, so box test also don't have. So box test don't have, multivariate also not valid. So again, it is repeated. No Mockley test result if the sample size is less than repeated measurement count. Okay, so p-value is not generated for the Mockley test. So you must assume that sphericity has been violated and you need to go for correction. Okay, why? Because epsilon estimates are measures of deviation and values close to 1 indicate little or no problem, while values below 1 indicate progressively more severe departures. Okay, you rely on the correction whenever the epsilon estimates are below 0.9 or 0.95. Okay, so you look at this table. These are the epsilon values. If the epsilon values is below than 0.9, then you have to look at the adjusted one. The degree to which sphericity is present is represented by a statistic called epsilon. And epsilon of 1 indicates the condition of sphericity is exactly met. The further epsilon increases below 1, the greater the violation of the sphericity. Therefore, you can think of epsilon as a statistic that describes the degree to which sphericity has been violated. So the lowest value that epsilon can take is called the lower bound estimate. And the lower bound estimate is simple. It is 1 divided by the degree of freedom. Okay, I repeat. Lower bound is the easiest epsilon value to be calculated. It is 1 as epsilon 1 divided by the degree of freedom. So degree of freedom, if it is 4, then 1 divided by 4. In our case, we have 4 trials, so degree of freedom is 3. So 1 divided by 3, it is 0.33. Okay. So that is the lower bound. The greenhouse geyser and the Hunefeld, they try to estimate the epsilon, but in a different way. Okay. And it is just an estimate because we are dealing with samples, not with populations. And these two values tend to differ. Okay, these are the two formula to calculate for greenhouse gaser and to calculate for the Hunefeld correction. Okay, I will not cover this in detail. Okay, because you have to look at your F value, then you get your P value, then you can calculate. Okay, sorry, the error. So you get the F test result and the error results. Okay, then you look at the degree of freedom. Okay, then you can get the greenhouse gas correction. For the Hunefeld, also from the F test, also from the degree of freedom. Okay, and you get the formula is different. Please look at the formula is low one, as I stated just now, it is 1 divided by the degree of freedom. In this example, I give 5, 0, 1, 2, 4, 6. So there are 6 comparison because you got 6 point in time. So degree of freedom is 4, so 1 divided by 4. So degree of freedom is 0.250. The one we had just now, time trial 1, 2, 3, 4. So 4 minus 1 become 3. So 1 minus 1 divided by 3, it is 0.33. Okay. I guess I have bird accompaniment. There's a bird singing right outside my window. Terus diam. Alright. So that's the story about the greenhouse gases and Hunefeld. So which one to choose? Okay. Which one to choose? Basically, as I said just now, lower bound, no point. The lower bound is the lowest epsilon value. So it is better try to estimate the correct value of the epsilon. So you have two choices, either greenhouse gaser or Hunefeld. Okay. If your epsilon is larger than 0.75, use Hunefeld. If your epsilon is larger than 0.75, use Hunefeld. If it is smaller than 0.75, use greenhouse gaser. G-E-I-S-S-E-R, gaser. Gay. Geezer. I don't know. Alright. So, we use greenhouse gaser. In this case, why? The epsilon is less than 0.75. That is just an example. But in our case, it is none of all these things. Okay, in our case, it's none of all that thing. Because why? Inside the examples given by Wai Chan, okay, we don't have that problem. We don't have that problem. Okay, you can see here, we have Hunefeld of 0.701, greenhouse gases of 0.544. So this one, since it is less than 0.75, we will take the greenhouse gaser value. So greenhouse gaser value is this one. So therefore, if this one was, if this one, the p value is smaller than 0.05, which one we will choose? Between greenhouse gaser and Hunefeld, we will have taken greenhouse gaser because the epsilon value is less than 0.75. Alright, so from that is how we choose. So here you can see this. What happens is you select greenhouse gaser instead of the Hunefeld. No difference whatsoever. They are all the same. Alright, and with that, I think we are done. Okay, I have explained in detail about all the different tests under univariate and multivariate, which is more than what I've done in the past. Okay, so as I explained just now, you use greenhouse gaser since gaser, greenhouse gaser. Are you gay, sir? Gay, sir. Uh, okay, so basically the results are all the same, but we end up taking the greenhouse gaser because of the epsilon is less than 0.75. But the answer is the same. Okay. All right. So that is in summary of my camera KO already. Very sorry. Camera KO. Okay. Okay, I'm back. All right. Okay. That's a story about GLM repeated measures. So we have given you all the necessary tools for your project. There's some jokers there on FB nak minta certificate of attendance. Aziz. Alright. Okay, let's not worry about that. Yang attend kat team pun nak minta certificate of attendance. Okay. So you can see here, we do the analysis. This one I demonstrate. If I do the same test using Anova, the result is the same like the test of between subject effects from the GLM repeated measures. It is 0.590 and 0.460. F of 0.590 and P value of 0.460. So you can see here, this is from the GLM repeated measures. This is from the Anova. Sorry, this is from the Anova. This is from the GLM repeated measures. Okay, so you get the same results. Sorry, aku cerita apa ni? Okay, very sorry about that. Okay, what happened was, I showed you earlier just now. I showed that if we derive the value, okay, we get the average of the number of errors between trial 1, trial 2, trial 3, trial 4 from the White-Shan examples. So when you have the trial 1, trial 2, trial 3, trial 4, you get the mean, you run the analysis for Anova, one-way Anova. So this is the top one, is the one-way Anova. So the one-way Anova, you can see that the F is 0.590, the P value is 0.460. So you can see here, it is the same result that the one we got from the test of between subject effects from the GLM repeated measures, which is also the same thing, 0.590 and 0.460. So 0.590 F value and 0.460 for the P value. Alright, and so I'm going to stop the FB one. So FB one, okay, bye bye FB. So I'm going to end the live video on FB. Okay.